Earth's evil twin. It's clouds made of battery acid. At 900 degrees, its surface hot enough to melt lead.
Venus is pretty much like the biblical vision of hell today.
This may be the most hostile real estate in the solar system. Yet billions of years ago, Venus looked a lot like Earth. Why it changed, nobody knows. A new probe is on a mission to find out. What turned Venus from a promising Eden into an infernal wasteland? And is Earth destined to end up like Venus? November 9th, 2005. A Russian Soyuz rocket launches from Kazakhstan, carrying a tiny European spacecraft called Venus Express. Its mission, to travel the 250 million miles to Venus and find out why the planet evolved so differently from Earth. For centuries, Venus's surface remained an enigma, obscured by layers of dense clouds. Because Venus is closer to the Sun than Earth, scientists assumed it would be hot and humid. Some even imagined a tropical paradise. The perfect hothouse for life.
Venus should be about the same temperature as the Earth. And that's what we thought back in the 50s and early 60s. We thought Venus should be like Miami, Florida.
What was really going on beneath the clouds? In the 1960s and 70s, while NASA explored Mars, the Soviet Union launched a probe to Venus. Codenamed Venera, the craft beamed back the first images of the planet's surface. Not a tropical paradise, but a hostile desert. Lots of dust and no water. Venus resembles its twin Earth in many ways. Similar in size and composition, they were probably formed from the same cloud of gas over 4 billion years ago. But unlike Earth, 85% of its surface is made up of extinct volcanoes and solidified lava. The clouds are composed of deadly sulfuric acid. Atmospheric pressure is 90 times greater than on Earth, enough to crush a car. But the biggest surprise is temperature. The atmosphere is nearly all carbon dioxide. As on Earth, this gas acts like glass in a greenhouse, admitting light, but trapping heat. On Earth, increasing levels of carbon dioxide are raising temperatures a few degrees. But on Venus, the greenhouse effect has pushed temperatures through the ceiling to levels hot enough to melt lead.
We get there to find out that it's 900 degrees Fahrenheit, and it was very shocking.
The surface is so hot, rocks glow in the dark. Venus would disorient a visitor from Earth. Under permanent cloud cover, you'd lose your bearings. No stars, no sun, no shadows. Instead, light is diffuse and an eerie red.
Think of a deep sunset color on the Earth, and then imagine that sunset color coming from every direction in this very diffuse sense. And that would be the light on Venus.
To find out how these two identical twins, Venus and Earth grew to be so different. Venus Express carries state-of-the-art instruments designed to unlock the planet's secrets. But the spacecraft's first challenge is just getting there in one piece. 5 months and 250 million miles later, the spacecraft nears Venus and the most dangerous stage. To achieve orbit will take perfect speed and timing.
Space is never really safe. There's always something that can go wrong, and you have to kind of provide for contingencies for that.
Too fast, and Venus Express will fly off into endless space. Too slow, and the planet's gravitational pull will bring it crashing to the surface.
You're falling faster and faster toward your target, and things is looming in the sky very quickly. The actual day of arrival, you have about an hour and a half that it's really kind of tricky. You want to make sure that you hit the right spot relative to Venus and that you're bending around Venus the right way.
To get into orbit, Venus Express must reduce speed by 3,000 miles an hour. April 11th, 2006. The engine fires to slow down the craft. For 10 minutes, Venus Express vanishes behind the planet. If it fails to achieve orbit, it's lost. No second chances. A 4-year mission hangs on hitting the brakes just right.
The most critical maneuver is happening out of sight and out of sound from the Earth. So it's a very harrowing time because you do lose communications for 10 minutes, and everybody's on pins and needles to see what happens.
At 9:57 a.m., Venus Express transmits a signal to Earth. The spacecraft's pioneering orbit begins. A multi-million-dollar quest to unlock Venus's secrets. But first, it has to get closer. On an elliptical course around the planet's poles, the craft drops down from 40,000 miles above the surface to just 155 miles. Now, the work begins. The technology on board is a quantum leap forward from the last mission to Venus in 1990. Before, a probe couldn't analyze Venus's surface without landing. All the probes had a short life, crushed by the pressure, melted by the heat, and corroded by the acid. With this mission, scientists have found a way to study the surface without landing and keep their probes safe. Venus Express views the planet using infrared, a wavelength not visible to the human eye. Unlike visible light, the infrared can penetrate areas of cloud that are less dense, allowing the probe to peer through the clouds to the clear atmosphere below. Now, for the first time, scientists can reveal Venus in 3D from the ground up.
With Venus, when you look with the visible eye, you're limited to the very top 1% of the atmosphere. The upper regions, you see these hazes. When you get the ability to look with the infrared light, it allows you to pierce right through all these hazes and see down much lower into the atmosphere. In fact, you can go to the surface.
From 155 miles up, scientists will exploit these infrared windows to map the surface in detail never before seen. Their map will document exactly how Venus and Earth differ. Then, they hope to find out why. To Despite decades of exploration, our sister planet can still surprise us. And soon, Venus Express makes a stunning discovery. A spacecraft orbits Venus on a mission to solve a mystery. Venus should be like Earth. But billions of years ago, our twin went its own way and evolved into the burning rock it is today. While studying the outer edge of the atmosphere, Venus Express discovers the first clue to what went wrong. It detects particles escaping into space, mainly helium, hydrogen, and oxygen. Hydrogen and oxygen make water. For years, scientists debated whether Venus's atmosphere held any water. Some argued if early Earth had water, so did Venus. Perhaps enough to form an ocean covering 90% of the planet. Yet Venus Express detects only a small amount of water vapor in the atmosphere. If you condensed all that vapor onto the whole planet, it would create a layer of water barely an inch deep. If Venus once had a vast ocean, what happened to it? Most scientists once thought it simply boiled away. But as Venus Express orbits the planet, scientists are forming a new theory. They believe the culprit is still the sun, but the cause is more than simple evaporation. The sun sustains life on Earth. It also blasts out a constant stream of deadly charged particles. They race out at speeds of up to 1,800,000 miles an hour. It's called the solar wind, and it can devastate unprotected planets. Surrounding Earth is a magnetic field that safeguards our atmosphere. This field is formed by movement in our iron core as the planet spins. But Venus has no magnetic field. Scientists believe it may rotate too slowly to generate one. The rotation is so slow, a day here lasts almost 2/3 of an Earth year. On Earth, one rotation takes 24 hours. On Venus, 243 days.
Well, without a magnetic field like Earth's, Venus is much more vulnerable to being affected by the solar wind and by energy in the upper atmosphere, stripping the atmosphere off into space.
Scientists now believe a combination of evaporation and solar wind strip the planet of its moisture. Venus is closer to the sun than we are, therefore hotter. Its primeval seas evaporated into the atmosphere. That water vapor might still be trapped in the clouds, if not for the solar wind.
The oceans ultimately boil off, and then when you have all that water as vapor in the atmosphere, it's very vulnerable to being broken up by ultraviolet sunlight into hydrogen and oxygen, and then the hydrogen escapes into space, and there you have it. After a few billion years, you've lost your oceans.
Scientists can reconstruct how this could have happened with simple chemistry. First, the sun's energy splits the water vapor into hydrogen and oxygen. Then the solar wind smashes into the atmosphere, ripping the molecules from the clouds. Over billions of years, the water is lost in space. The oxygen and hydrogen detected in the atmosphere are the last drops of those ancient oceans. Loss of water turned Venus from a warm, wet planet to a burning rock. The atmosphere changed too, from water vapor to carbon dioxide. Ancient volcanoes released trillions of tons of CO2 and set off a chain reaction, a runaway greenhouse effect, leading to global warming gone mad.
The energy for both climate and weather on planets all comes from sunlight. So now imagine that this is sunlight heading towards the surface of a planet. And on a planet like Earth, where there's not much atmosphere, as represented by these atmospheric molecules here in blue, most of the sunlight will miss the atmosphere and just make it to the surface. And occasionally you'll have sunlight scattering off an atmospheric molecule. But for the most part, you just have these yellow rays of sunlight reflecting off the surface. Now, let's set up again and look at what happens on Venus. And I'm putting much more gas in the atmosphere because now we're simulating Venus, which has 100 times as thick an atmosphere as Earth. Okay, so here's our thick Venusian atmosphere. Here we are back out in space, and let's see what happens to the sunlight in this much thicker atmosphere on Venus. And you'll see maybe a very occasional ray of sunlight hits the surface, but in almost all cases, it gets absorbed in the atmosphere.
The trapped sunlight heats up Venus's atmosphere, and any sunlight that reaches the surface worsens the situation.
So here we are on Venus, our hot surface radiating infrared. And is it making it out into space? Generally, no. Not only is it getting absorbed into the atmosphere, but some of it is bouncing back to the surface. And so on Venus, the infrared radiation is trapped by the thick atmosphere, and the surface and the atmosphere end up heating up.
The process resembles what's happening on Earth, but on Venus, it's out of control. Earth's twin is now the hottest planet in our solar system, even hotter than Mercury, the planet closest to the Sun. Venus is the poster child for climate catastrophe, devastating global warming, and a cosmic hellhole. If Earth were nearer to the Sun, it would look like Venus.
The major difference between Earth and Venus in terms of the evolution of the planets is all about Venus being closer to the Sun. We think that they formed kind of as identical twins, and then it's a different sort of experience of growing up in slightly different neighborhoods closer to the Sun and farther from the Sun that led to this huge divergence we see today.
Life on Earth may be a lucky break, but in the end, we share the same fate.
If you think of the long-term future of the Earth, Earth will go the direction of Venus because the Sun is heating up. And I'm not talking about on a short time scale. If we think about billions of years in the future, really, cosmological time scales, then Earth is destined to end up like Venus.
Scientists long guessed Venus was once like Earth. Venus Express has shown how it evolved into a barren world. More revelations lie beneath the clouds. On the surface, the clouds look calm. But when the spacecraft switches on its infrared thermal imaging spectrometer, its images show how the scene transforms. Violent storms rip across the planet. At the poles, monster cyclones churn the atmosphere. Storm systems that make Earth's worst weather look like a breeze. As scientists study this mysterious planet, they make a startling observation. While Venus rotates slowly, its atmospheric winds travel fast. Venus Express observes winds circling the planet in a mere 4 Earth days. That's 60 times faster than the planet's rotation speed. Scientists call this superrotation. If Earth were like Venus, winds would whip around the planet in just 30 minutes. A speed of 50,000 miles per hour.
When you think about the rotation of the Earth, you've got the rotation rate of the solid planet, 24 hours, and then the atmosphere sort of going along for the ride. But with Venus, it's almost as if the atmosphere doesn't really care what the solid surface is doing. It's got a mind of its own and is rotating much faster than the solid surface.
On Earth, wind speed nearly matches rotation speed. So why do Venus's winds travel so much faster than the planet spins? The answer lies in the clouds. On Venus, the cloud layer is up to 12 miles thick. So thick, only a small amount of solar energy reaches the surface. Much of this energy is retained in the upper clouds, 40 miles above the surface. This energy starts the clouds moving at breakneck speeds. Because Venus is closer to the Sun than Earth, the greater the solar energy in its clouds, and the greater the wind speeds. Winds rare on Earth, over 200 miles an hour, are typical on Venus. Venus Express is equipped to solve a riddle found by an earlier mission. A vortex at Venus's North Pole, similar to vortices on Earth. We call them hurricanes. On Earth, they form when warm, moist air from the ocean is heated by the sun and rises to form clouds. As more energy enters the system, the clouds start to spin, creating a hurricane. But Venus has no warm oceans for fuel. So what powers its hurricanes? Venus Express swings down to the southern hemisphere for a closer look. What it finds blows scientists away. A vast hurricane-like vortex, 1,200 miles wide and 13 miles deep. 4 times larger than the largest hurricane on Earth. Not one, but 2 rotating eyes. Scientists believe the cause of the vortices is not only super-fast winds, it's the very motion of the planet.
A huge vortex is caused by all the air flowing in from the equator, and then it has to sink somewhere, which causes this enormous vortex, which is some 2,000 kilometers across.
Wilson believes air from the equator flows to the poles, where it's sucked down to form the vortex. But this air doesn't move in a straight line. The planet's rotation deflects its motion. He suggests this process, called the Coriolis effect, produces the giant vortices.
Let's explain the Coriolis effect using this rotating table. It's the same for a rotating planet. If I let this ball roll across the table, you'll see that it runs in a straight line. And that's because you, the observer, are stationary. You're not rotating with the table. Whereas if, on the other hand, we switch to a camera angle or another observer who's rotating with the planet, this ball will appear to travel in a curved trajectory. So if the observer is rotating with the planet, then it appears that objects experience a force to the right. And this works not only for balls, but also for parcels of air in the atmosphere. If the air at Venus is heated at the equator and moves towards the poles, it's then bent towards the right if it's in the southern hemisphere, or towards the left if it's in the northern hemisphere.
As the winds move toward the poles, the Coriolis effect makes them spin, which creates the vortex. Wilson's theory seems logical. Vortices also occur at Earth's poles. But while Earth's polar vortex is relatively stable, the double-eyed monster on Venus is an ever-shifting whirlwind. To find out what makes the vortex so chaotic, recreate it. Wilson uses water to simulate Venus's atmosphere.
We've got the rotating atmosphere simulated by the rotating tank, and then we've got this thin ring here which spins at a different speed, faster than the rest of the atmosphere. And what we find is that the flow in this region is unstable, it sort of oscillates in and out. And we think that's quite representative of what happens around the edges of the polar vortex on Venus.
When Wilson adds dye, his simulation reveals the shifting shapes at the edge of the vortex.
And this whole thing is affected by the spinning of the planet. It turns out that the vortex is not stable. It shifts all over the place. You have two-sided, three-sided structures changing from day to day. It's a tremendously turbulent place, and it's fascinating to look at.
These chaotic winds show the power of Venus's atmosphere. But vortices aren't the only bizarre weather. On June 9th, 2006, Venus Express discovers an eerie phenomenon. The spacecraft detects an intermittent disturbance that sounds like a whistle. A brief, low-frequency electromagnetic burst. This is the actual recording. To anyone else, baffling. But to the mission team, a revelation. The signature of lightning. UCLA's Professor Christopher Russell has long believed lightning occurs on Venus. The spacecraft's discovery presents a riddle. On Earth, water drives thunderstorms. Warm, moist air collides with cold air. Water droplets and ice crystals rub together, creating positive and negative charges. The electrical buildup discharges as lightning. Venus's atmosphere has little water. Most of it has been stripped away by the solar wind. So what else could produce lightning? Thanks to data from Venus Express, a controversial theory gathers new weight. Russell's candidate for the cause of lightning? Clouds of sulfuric acid. On Earth, sulfuric acid clouds form when sulfur dioxide is released from volcanoes and mixes with water vapor. The same thing happens on Venus. 2 decades ago, Project Magellan, the first spacecraft to map Venus, discovered widespread evidence of a volcanic past. Over eons, volcanoes release trillions of tons of sulfur dioxide. Some remained as a gas. The rest mixed with water vapor to form sulfuric acid clouds. The speeding winds energize these acid clouds and create ideal conditions for lightning.
We think now that it's sulfuric acid clouds and Venus's winds, and the winds can then provide the energy source in the cloud for the charge separation.
Sulfuric acid does on Venus what water does on Earth. Acid drops rub together and create positive and negative charges.
I was looking for lightning and looking for the proof that it really existed, and to find it is like a personal victory.
The discovery of lightning is electrifying. Lightning is an ingredient of life. An even greater shock was in store. The hellish planet might not be dead. Eons ago, Venus's volcanoes spewed out vast clouds of sulfur. But today, tests show the level of sulfur is fluctuating. Since volcanoes discharge lots of sulfur only when they erupt, the fluctuations mean one thing. The volcanoes on Venus must still be active. Scientists have found active volcanoes in only a few places besides Earth. In 2007, the New Horizons probe captured an eruption on Io, one of Jupiter's moons. To find active volcanoes in the inner solar system is big news. It means Venus may not be a dead rock, but a living planet. Venus Express takes a closer look. The probe exploits the infrared windows to peer through the clouds. Below, mountains and valleys, smooth plains, impact craters, and flat-top features like pancakes, all made of lava. 85% of Venus's surface is paved with lava. Why so much? Puzzled scientists. To understand Venus's vast lava fields, scientists look to its calmer twin. Earth's crust is made up of interlocking tectonic plates that drift over its liquid mantle. Most of our planet's volcanic activity is found where these plates move together or pull apart, allowing heat from the core to escape. No mission has ever found evidence of plate tectonics on Venus. Its crust is solid. Without plate tectonics to cool Venus, scientists suggest heat from the core built till it couldn't be contained. Then virtually the whole planet erupted, releasing so much lava, it recycled the crust and resurfaced the planet.
This is a demonstration of the Venus resurfacing. We're going to demonstrate with some pudding in a pan over a hot plate. And this heat from the hot plate represents radioactive heat from the inside of Venus. And here we're seeing the first signs of the interior heating the crust on the surface. And that crust is stagnant. It's not moving, it's keeping the heat inside. And perhaps at this moment the surface might even crack in some places, and the molten material, the molten rock under the crust, would erupt and flow out onto the surface, covering up all the craters and all the mountains. And at this point, we can see several small volcanic eruptions along those fissures.
Scientists date the resurfacing to 500 million years ago. A slow process that took tens of millions of years. This cataclysmic series of eruptions released trillions of tons of sulfur dioxide and carbon dioxide, replenishing what the solar wind removed. Yet surveys of Venus reveal not all the planet was resurfaced. Rocks in the highlands are much older than the lava covering most of the planet. They offer a clue to conditions in the distant past. Kevin Baines discovered these rocks weren't born on dry land.
On Venus, most of the rocks are basalts. They're made out of volcanoes spewing out their lava. But we have found a very interesting result in the last few months. That is, the highlands are special. On the highlands, the tall mountains of Venus, we're finding evidence of rocks that were created in the presence of water, as if billions of years ago they were formed perhaps in an ocean, and then geologic processes have risen them up since then.
The rocks provide hard proof that Venus once had oceans, which raises a provocative question. On Earth, life began in the oceans. The other ingredient to kickstart life is lightning. And lightning occurs on Venus. If Venus had water and lightning, did it once have life? Scientists have plenty of proof that Venus and Earth were once twins, and that Venus had two of the ingredients of life: water and lightning.
Lightning is important because it's something that produces exotic species. For example, nitrogen and oxygen combine to produce nitrogen oxides, which are important for life and important for producing chemicals that can't be produced any other way in a planetary environment.
With water and the means to kickstart evolution, perhaps Venus once had life, and maybe still does. The first clues arrive from Venus Express. 155 miles above the surface, a camera is switched to ultraviolet. Unlike infrared, the shorter wavelength of UV is scattered by Venus's cloud layer, enabling the scientists to explore the upper regions of the atmosphere. Their images reveal intriguing dark markings where more UV is being absorbed. This shows that something besides sulfuric acid is trapping sunlight. The mission team calls the dark areas absorption patches.
There's been great interest in the ultraviolet absorbers on Venus. They absorb about half of the sunlight that's hitting the planet. They're in the clouds of Venus, and it's been suggested that they might be associated with life forms.
Life forms, like microbes, living in hurricane-force winds and sulfuric acid clouds, using UV light in some weird photosynthesis. But what kind of life could survive such conditions? Biologist Lynn Rothschild studies organisms that live in extreme environments. She has discovered microbes called extremophiles thriving in some of the harshest conditions on Earth, like Yellowstone National Park. With the highest concentration of thermal springs in the world, it opens a window into how life might survive on Venus.
What you see behind me is really ground zero for where people started to understand organisms that could live in extremely acidic conditions. Before that, people thought conditions like lemon juice would be totally outside the realm of where a living organism could be.
These geysers, powered by volcanoes, mimic conditions on Venus, hot and acidic.
This stream is just phenomenal. It's about pH 3, it's about 40 degrees centigrade. A little hotter than warm to the touch. Actually, it's fairly warm to the touch. What you see in here is almost a pure culture of some red algae. I know it looks green, but they are actually red algae that don't have a red pigment.
Extremophiles like these can survive in battery acid and temperatures above boiling point. These organisms have evolved to survive not only the heat and the acid, but levels of other chemicals that would kill most life.
These particular organisms, Cyanidium, are really neat because not only do they live at low pH and in warm temperatures, and they photosynthesize, but they've been shown to be able to survive in pure CO2, pure carbon dioxide. Even Venus doesn't have as high a carbon dioxide level as that.
The organisms show life can survive hot, acidic carbon dioxide-rich environments, like Venus. If life can survive in Yellowstone, why not on Venus? Scientists believe the surface itself is too savage. Temperatures reach 900 degrees, and the pressure is bone-crushing. But not in the clouds. 30 miles up, temperatures reach only 176 degrees, much closer to the kind of heat microbes endure on Earth. Could life have begun in Venus's ancient oceans? When the water evaporated, the microbes may have gone with it. Here, in the cooler acidic clouds, they could survive. But how can life exist without water?
There is water vapor up in the clouds in Venus, and we have some indication that organisms on the Earth, for example, lichens, can use water vapor as their source of water. So that's pretty encouraging for life in the clouds, at least in terms of having water available.
To see if life exists in moist, acidic clouds, Rothschild collects air samples above a hot spring. The acidic steam mimics the clouds of Venus.
Well, I can see a little green on the mass here. That's encouraging. Maybe there really is something in there.
Analysis shows microbes can exist in hot, acidic steam, suggesting life may survive in Venus's clouds. To further test the theory, Lynn sends organisms high into the atmosphere. She's launched a whole spectrum of microbes.
Once it clears that weight by itself, that matches the weight, or it's only a little more.
Some to over 100,000 feet. A zone where temperature and pressure drop so low, most life would die.
Okay. Now let's hope we put enough in it.
Many of her subjects survived. Some researchers have even found organisms that can reproduce high up in the atmosphere.
The clouds on Venus are continuous and long-lived. So you could imagine creatures that live in the clouds and reproduce in the clouds and even seed other cloud particles. And they're not going to last forever because they're going to fall out, but as long as they last long enough to reproduce themselves, then you could have a self-sustaining colony of life in the clouds.
Research shows life in hot, acidic clouds is theoretically possible. Perhaps microbes live in the clouds of Venus, hidden in those strange dark patches. Venus Express has traveled 87 million miles around the planet and completed 100 weeks of collecting data. It proved that Venus once looked like Earth. A habitable climate, vast oceans, perhaps even life. But too near the sun, Venus was doomed. Earth blossomed, Venus burned. Yet even here, life may thrive. Maybe tucked in blankets of clouds. We may have to wait years for the secret to be revealed. But someday, another mission to Venus may find the holy grail of space. Life beyond our world.